Dear students, I hope you will be fine. आज की हम बात करेंगे सिग्नल की एक और क्लासिफिकेशन के बारे में। लास्ट लेक्चर में हमने बात की थी कि सिग्नल्स जो हैं वो क्लासिफाई किए जा सकते हैं, डिफरेंशिएट किए जा सकते हैं ऑन द बेसिस ऑफ इवन एंड ऑड सिग्नल्स और पीरियाडिक एंड अपीरियाडिक सिग्नल्स। कुछ सिग्नल्स जो हैं वो आपके पास इवन होते हैं, कुछ ऑड होते हैं, सिमिलरली कुछ पीरियाडिक हैं, कुछ अपीरियाडिक हैं। इसी तरह की एक और क्लासिफिकेशन, एक और डिफरेंस जो सिग्नल्स के दरमियान एग्जिस्ट करता है, चाहे वो डिस्क्रीट टाइम सिग्नल्स हों या कंटिन्यूस टाइम सिग्नल्स हों, वो बेसिकली ऑन द बेसिस ऑफ देयर energy or power exist करता है. So we will talk about what are energy signals, what are power signals, and then there are few signals which are neither energy signals nor power signals. So इस lecture के बाद, आज के lecture के बाद, you will be able to differentiate amongst signals on the basis of their size or on the basis of their duration. So आज के इस लेक्चर में हम ये भी देखेंगे कि किस तरह के सिग्नल जो हैं वो नॉर्मली एनर्जी सिग्नल्स होते हैं और किस तरह के सिग्नल्स जो हैं वो पावर सिग्नल्स होते हैं. So let's start our discussion with energy signals. So energy signals जो हैं वो सिग्नल्स हैं जिनकी एनर्जी जो है वो फिनाइट होती है. अगर हम किसी भी सिग्नल के बारे में बात करें तो उस सिग्नल में एक इम्पॉर्टेंट पैरामीटर जो है वो उस सिग्नल का साइज़ है. जब हम साइज़ की बात करें तो वी आर नॉट ओनली टॉकिंग अबाउट द इंडिपेंडेंट वेरिएबल, वी आर आल्सो टॉकिंग अबाउट डिपेंडेंट वेरिएबल. लास्ट लेक्चर में हमने बात की थी कि जो सिग्नल का एम्पलीट्यूड है विद रिस्पेक्ट टू टाइम, इफ़ वी आर टॉकिंग अबाउट कंटिन्यूस टाइम सिग्नल, सो दैट वुड बी अ डिपेंडेंट वेरिएबल. सिमिलरली जो टाइम टी है एक कंटिन्यूस टाइम सिग्नल में, वो एक इंडिपेंडेंट वेरिएबल है. सो जब हम सिग्नल के साइज़ की बात करते हैं तो इन दोनों क्वांटिटीज़ की हमें बात करनी पड़ेगी कि वो सिग्नल कितनी ड्यूरेशन के लिए एग्जिस्ट करता है और उस सिग्नल का एम्पलीट्यूड क्या है, बिकॉज बोथ ऑफ दीज पैरामीटर्स विल डिटरमिन द साइज ऑफ अ सिग्नल. सो न सिर्फ उस सिग्नल का एम्पलीट्यूड इम्पॉर्टेंट है बट आल्सो इट्स ड्यूरेशन इज़ इम्पॉर्टेंट. ड्यूरेशन मीन्स के सिग्नल जो है वो कितनी ड्यूरेशन के लिए एग्जिस्ट करता है. अगर हम ड्यूरेशन की बात करें तो हमारे पास कुछ सिग्नल्स ऐसे होते हैं जो इन्फिनिट ड्यूरेशन सिग्नल्स कहलाते हैं. इन्फिनिट ड्यूरेशन सिग्नल्स की डेफिनेशन ये है कि ये सिग्नल्स जो हैं ये नॉर्मली इन्फिनिट ड्यूरेशन के लिए एग्जिस्ट करते हैं. फ्रॉम ज़ीरो टू इन्फिनिटी और फ्रॉम माइनस इन्फिनिटी टू प्लस इन्फिनिटी देयर एम्पलीट्यूड इज़ नॉन ज़ीरो, और फ्रॉम माइनस इन्फिनिटी टू ज़ीरो. वेरियस टाइप ऑफ इन्फिनिट सिग्नल्स हो सकते हैं, लेकिन एक चीज़ जो आपको याद रखनी चाहिए वो ये कि इन तमाम सिग्नल्स में इनका एक एंड जो है that is at infinity, whether it is minus infinity or whether it is plus infinity or both. So ऐसे सिग्नल्स जो हैं जो infinite duration सिग्नल्स होते हैं, अगर हम उनका साइज़ मालूम करना चाहें तो वो साइज़ हम मालूम कर सकते हैं. इवन फिनाइट ड्यूरेशन सिग्नल्स का भी मालूम कर सकते हैं, नो मैटर वेदर इट इज़ finite duration or infinite duration. When we talk about the size of a signal, then thing which is used to measure the size of signal is called the strength of the signal. So strength, basically we want to determine the strength of a signal. So अगर आपके पास कोई भी सिग्नल है xt, तो हम उसकी सिग्नल की स्ट्रेंथ जो है वो कैसे मालूम कर सकते हैं. सो अ फर्स्ट आइडिया कुड बी कि अगर हम उस सिग्नल को जो है वो एरिया अंडर दैट सिग्नल जो है वो मालूम करें. बट एरिया अगर हम सिग्नल x ऑफ t जो है वो पॉजिटिव भी हो सकता है, वो नेगेटिव भी हो सकता है। जैसे फॉर एग्जांपल आप साइनोसाइडल वेव लेते हैं तो फॉर हाफ साइकिल दैट वेव इज पॉजिटिव एंड फॉर द नेक्स्ट हाफ साइकिल दैट वेव इज नेगेटिव. So if we want to determine the signal energy or the signal strength, a better idea is to find the area under the square of the signal. And if we find the area under the square of that signal, then that is basically defines the energy of signal. So if we are talking about, say, a continuous time signal, so in case of continuous time signal, the definition of signal energy is E of x, where x is the signal is given like this: an integral from minus infinity to plus infinity, square of the absolute value of x. We integrate this square with respect to time, and the answer which we will get will be the signal energy is the signal energy. Similarly, if we are talking about discrete time, both of these definitions are analogous. So in case of discrete time, we instead of taking integral, we take a summation and goes from minus infinity to plus infinity, and we sum all the values of discrete signal x of n, square of x of n, from minus infinity to plus infinity. So these are the definitions of signal energy. So अगर आप ये बात, अगर आपके पास कोई सिग्नल जो है वो एनर्जी सिग्नल है, तो एनर्जी सिग्नल वो तब होता है अगर उसकी एनर्जी जो है वो फेनाइट होगी. अगर किसी सिग्नल की एनर्जी फेनाइट ना हो, यानी ये जब आप इंटीग्रेट करेंगे या जब आप ये सम फाइंड करेंगे किसी डिस्क्रीट टाइम सिग्नल के लिए, तो जो आंसर आपको मिलेगा, अगर वो आंसर फिनाइट नहीं है, तो देन दैट वुड नॉट बी एन एनर्जी सिग्नल. एनर्जी सिग्नल सिर्फ वही होगा जिसमें जब आप ये इंटीग्रेशन परफॉर्म करें कंटिन्यूस टाइम के लिए या ये समेशन का रिजल्ट कैलकुलेट करें फॉर डिस्क्रीट टाइम, तो आपके पास जो इस ई ऑफ एक्स का आंसर आना चाहिए, दैट शुड बी अ फिनाइट आंसर. ई ऑफ एक्स मस्ट बी लेस देन इन्फिनिटी. सो इफ दैट कंडीशन इज सेटिस्फाइड, तो ओनली देन दैट टाइप ऑफ सिग्नल is called an energy signal. So अगर हम continuous टाइम की बात करें, तो जैसे ही आपका independent variable t, when it approaches infinity, it approaches infinity, the amplitude of signal must approach zero. If you have a signal whose amplitude does not approach to zero as t approaches infinity, then probably that signal would not be an energy signal, because when you will find this integral, the result of this integral will not be finite. Similarly, in case of discrete time, as n approaches infinity, the signal amplitude must go down to zero. If it goes down to zero, then it could be an energy signal. But if it does not go down to zero, then basically it means that the signal exists for infinite duration, because that is the very basic definition of an infinite duration signal, that it exists from one end of that exists up till plus infinity. So now let's take an example. Let's suppose we have this signal x of t, which is only non-zero in this interval from 0 to 2, and the amplitude of this signal in this interval from 0 to 2, from the values of t 0 to 2, the amplitude of this signal is 3. Elsewhere at every point this signal is 0. From minus infinity to 0, this signal is 0. Similarly, from plus 2 to infinity, this signal is equals to 0. So we want to determine whether this is an energy signal or not. And as you can see from this diagram, this signal is basically falls in the category of signals which are called finite duration signals. Finite duration signals are those signals which only exist for a certain period of time and then they become zero. So this signal only exists from the values of t, which range from 0 to 2. Okay, so in order to find the total energy of this signal, By definition, this is the definition of signal energy which we discussed in the previous slide. We integrated from minus infinity to infinity the square of xt dt. So since this signal is 0 from minus infinity up till 0, so we can subdivide this integration into three integrals: an integral from minus infinity to 0 where the value of xt is equals to 0, plus an integral from 0 to 2 where it has a non-zero value, and then from 2 to infinity where it is again equals to 0. So the value of signal in this integral is 0. Similarly, in this integral is equals to 0. So we are only left with one integration which we have to perform, and that is within the limits from 0 to 2. The value of signal from t is equals to 0 to t is equals to 2 is 3. If we square that value, that will become 9. So if we integrate and put the limits, the total energy contained in this signal will be equals to 18 joules. Sorry, I forgot to write the unit, but unit will be joules. So 18 joules of energy this signal has. So since its energy is finite, so that's why this signal will be an energy signal. Now moving forward, now let's talk about the power of the same signal, the signal which we discussed in the previous slide. Let's discuss what would be the average power of that signal. The average power of a signal is defined as, average power has a definition: total power divided by total time. So we can calculate the instantaneous power present in the signal by integrating it from minus infinity to plus infinity, and with respect to time. So it is an integral from minus infinity to plus infinity, the square of xt and dt, and we have found this value in the previous slide. So this value is finite, but when we divide this finite value with the total amount of time, the amount of time is infinite, because the signal duration basically is from minus infinity to plus infinity. So if you integrate this with the total amount of time, then average power will become equals to 0. So whenever a signal has a finite energy, which means it is an energy signal, the average power in that signal will be equals to 0. So for an energy signal, the average power in that signal equals to 0. So now let's see, if the amplitude of a signal does not go to 0 as the time t in continuous case or n in discrete case tends to infinity. So let's see what happens if the signal amplitude does not go to 0. Obviously, now we are talking about an infinite duration signal, a signal which exists from say minus infinity to plus infinity, or from 0 to infinity. So the value of the amplitude of the signal does not go to 0 as t tends to infinity. So obviously, if now we are going to find the energy of that signal, that probably would be equals to infinite, because we are calculating the area from 0 to infinity, and infinite duration signal it is. So इस वजह से इसकी जो energy होगी, that would be equals to infinite. So instead of finding the energy in that signal, now we find another quantity which is called signal power. So signal power is defined as p of x, power in signal x is limit t tends to infinity 1 upon 2t, an integral from minus t to plus t x t square dt. So we are basically integrating within an interval, and since this t tends to infinity, so basically this integration is from minus infinity to plus infinity. So we are taking all the values of signal from minus infinity to plus infinity, and we are integrating, we are finding the area of square of that signal, and then we divide it by 2t, which is the interval length. This interval is from minus t to plus t. So basically this interval is length is duration is 2t. If signal is periodic, which would be the case in few scenarios. In the last lecture we talked about the periodic signal. Basically these are the signals which repeat themselves after a fixed interval of time. So if signal is periodic, then its power can be calculated as from 0 to t in one time period. We integrate the square of the signal and divide it by the total by its time period, which is obviously equals to t. And similarly is the case for a discrete time signal. Discrete time signal, since the signal is discrete, so we will replace an integral with this summation. So we calculate from minus n to n. Basically these are 2n plus 1 are the total number of points. Total number of points is 2n plus 1 due to the value at n is equals to 0, and we sum the values of this signal, square of the values of this signal, and divide it by 2n plus 1. And as n goes to infinity, if the answer of this px comes out to be finite and non-zero, then it would be a power signal. Similarly, for periodic case, we can integrate, we can take sum from 0 to n minus 1 and divide it by 1 over n. So a signal will be a power signal if and only if its power, which we calculate using these relationships, comes out to be finite. If power is finite and non-zero, only then it would be called a power signal. So a power signal, which we normally encounter in our examples, which we will discuss sometime later, a power signal must necessarily have infinite duration. So normally the power signal जो जिसको हम कहते हैं कि ये power signal है, normally it has an infinite duration. So it exists from say 0 to infinity, or from minus infinity to plus infinity, and so on and so forth. So all periodic signals which we will encounter in this course, they are power signals. So all periodic signals are power signals, but the converse is not true, which means all power signals necessarily are not periodic. But if you have a periodic signal, obviously it would be a power signal. So all periodic signals are power signals, but all power signals are not periodic. Okay, so if we talk about the energy signal and the power signal, we have already talked about that, but graphically if we want to look how the energy signal looks like and how the power signal looks like. So an energy signal, as you can see, is a signal which has a finite duration. This energy signal only exists from this point up till this point. So it is a signal which has a finite duration. So obviously if we are going to calculate the energy of this signal, hopefully the energy of this signal will be finite, and that's why it is called an energy signal. But if you look at the bottom signal, this signal exists from minus infinity to plus infinity. This is an infinite duration signal. So such type of signal which exists for an infinite duration of time is normally not an energy signal. So most probably this type of signal which you will encounter will be a power signal. A power signal which has a finite amount of power, but it will have an infinite amount of energy because it exists for an infinite duration. Whereas energy signal has a finite amount of energy. It only exists for a finite duration of time, and it would have zero average power. Okay, so uh, if we conclude what we have already discussed in this lecture, a signal may be an energy signal. What we meant by energy signal means that signal has finite energy and zero power. An example of that signal could be a signal which exists for t greater than equals to 0, less than equals to 1, and 0 otherwise. So this is a finite duration signal. If you will calculate its energy will come out to be 1, which is a finite number. Its power will be equals to 0. Similarly, a power signal has finite power, but it has infinite amount of energy. For example, a signal x of n, which is equals to 4 for all values of n. So if we take its energy will be infinite because it exists for an infinite duration, and its power will be equals to 16, which is a finite number. So that's why it would be a power signal. However, sometimes we have some signals which are neither energy signals nor they are power signal. An example of such a signal is x of t is equals to t. If you draw this signal x of t is t, it would be something like this. It will exist for an infinite duration, a straight line which is increasing with the value of t, and this type of signal is neither energy signal nor it is a power signal. If you are going to calculate its energy and power, both of them will be infinite in nature. So it would not be an energy signal, neither it would be a power signal. So let's briefly recap what we have discussed in this lecture. We discussed that signals can be classified on the basis of energy signals, power signals, or neither energy nor power signals. If we are talk about energy signal is such a signal which has a finite amount of energy and zero power, and normally this type of signal exists only for a short duration of time, or we can say it is a finite duration signal. Whereas power signals, they are normally exist for an infinite amount of time, for infinite duration they exist. They are normally also periodic. All periodic signal in fact are power signal. They have finite amount of power, but they have infinite amount of energy. And finally, we have some signals which can be called neither energy signal nor power signal. इस तरह के सिग्नल्स जो हैं वो ना तो उनकी एनर्जी फिनाइट होती है, ना उनकी पावर फिनाइट होती है. सो इस वजह से ना हम उनको एनर्जी सिग्नल कह सकते हैं और ना ही हम उनको पावर सिग्नल कह सकते हैं. सो होप यू learned from this short lecture. Inshallah, next time hopefully we will discuss about the signal transformations. Transformations are operations on independent variable and dependent variable. So till then, Allah Hafiz, and thank you very much.